All right, welcome back. So in this video, we're going to combine what we just did with budget constraints with our work on indifference curves before to try to understand what it looks like when someone makes an optimal choice. The way that we're going to do that is we're going to remember that budget constraints and indifference curves both essentially separate your options into two categories. So if we start with budget constraints, right, we've got our toppings and we've got our froyo. We've got a budget constraint like this, 4 and 6, right? This area here is affordable, right? Anything below our budget constraint is going to be affordable, so I'll shade this in blue. And anything above our budget constraint is unaffordable. Right? And I'll shade that in red. So we know, right, that anything that's our optimal choice has to be in the affordable range. If it's not affordable, we can't do it. But indifference curves are also going to separate the world into two categories, right? If we pick a spot, let's say we pick this choice here, and we draw the indifference curve through that point. Right? I'm just making up a curve here, right? We're drawing the indifference curve through this point. This is also going to separate all of our options into two categories. In this case, it's going to separate them into options that are worse, right? And options that are better. Right? Everything below the indifference curve is worse than everything on it, and therefore worse than this choice that we were considering. Right? So all of this is worse. And everything above the indifference curve, which is this area here, right, is going to be better. So given this, if we look at this picture, is this our optimal choice? Could this possibly be our optimal choice? I want you to think about that for a second. So I'm going to say this can't possibly be optimal. And the reason this can't be optimal is because there's alternatives like this one that are both affordable, right? They're on or below the budget constraint, and they're better, right? They're above the indifference curve. So this is not our optimal choice. And the reason for that is because there's an overlap between the world of better and the world of feasible, right? So this can't be our best feasible choice. Okay, so given that, what's it going to look like when we are making our optimal choice? When our choice is as good as possible? Well, it's going to have to look like having an indifference curve that only touches our budget constraint in one spot, right? If we have multiple spots, we have overlap above the indifference curve and within the budget constraint, we're not optimal. So we have to have the indifference curve just barely touch the budget constraint. So one way this might look is if we had an indifference curve like this, right? We had an indifference curve like this. In this case, if we looked at this choice here, we would say everything better, right, up here, isn't going to be affordable, right? The universe of better, the universe of affordable, completely separate. So this is one way that this might look. The other way that it might look, right, to have an indifference curve that only touches the budget constraint at one point, is instead of having the indifference curve touch at one of the extremes, we have it touch somewhere in the middle, right? So we might have an indifference curve that looks like that, right? So that it touches our budget constraint only at one point. And here too, right, we have better up here. We have worse down here. Every single option that's better, every single option that's above this indifference curve is not going to be affordable, right? So that's really the fundamental takeaway here, is when we're trying to solve a constrained optimization problem, we need to find a solution where everything above the indifference curve is not within our budget set. And in the next video, we're going to talk through how to solve mathematically for these two kinds of solutions. The kind I'm showing you here, which I'm going to call an interior solution, and the kind I showed you last, where we're on one of the edges, which I'll call a corner solution.